Good morning, dear student. My name is Divakar Pant and today we are going to discuss Super Heterodyne Receiver. Super Heterodyne Receiver is one of the very famous receiver used in the communication systems for receiving the electromagnetic signals. So, before going to the detail of Super Heterodyne Receiver, let's discuss some basic function of a receiver. What is a receiver used for? A receiver is used for intercepting the electromagnetic waves in receiving antennas to produce the desired radio frequency modulated carrier. Second thing is select the desired signal and reject the unwanted signal. Means it is not always that our desired signal is there are some unwanted and undesired signals are also there, so we have to reject those signals and we have to select our desired signal. So this is also the function of a receiver. Amplify the radio frequency signal, whatever signal we have received that might be we can say a very low in the amplitude or in the voltage, so we have to amplify the signal to the our we can say our according to our system requirement. Detect the radio frequency carrier to get back the original modulating or modulation frequency voltage. As we know that we have a modulating signal, then we will modulate that signal with the help of a carrier, and that signal is known as a modulated signal. That and then when at the receiver side we receive that modulated signal, our aim is to get back our message signal or modulating signal back. So that is also the we can say a function of a receiver. And amplify the modulation frequency voltage, and whatever frequency we have received we have to modulate it, we have to amplify it to the suitable level. So these are some features of the receiver. It should be simplicity of the operation. Your receiver should be simple in the operation. It should have good fidelity, good sensitivity and good selectivity, and adaptability to the different type of aerials. So these are some of the features of the receiver. So in this section we will discuss about the Super Heterodyne receiver. So I'm just going to read the definition of a radio receiver. A radio receiver is an electronic equipment which picks up the desired signals, rejects the unwanted signal, it amplifies the desired signal, demodulates the modulating signal to obtain back the original modulating signal. So before the use of Super Heterodyne receiver, normally we can say tuning frequency modulators were used, but there are some disadvantages of those, and those receivers are obsolete now. So Super Heterodyne receiver is used. So this is the block diagram of a Super Heterodyne receiver. First we have an antenna, then we have an RF stage. RF stage means radio frequency stage. Then we have a mixer over here. Mixer is connected to the local oscillator, and output of the mixer is given to the IF amplifier. IF means intermediate frequency amplifier. Output of the intermediate frequency amplifier is given to the demodulator circuit, and output of the demodulator is given to the audio amplifier, and then it is given to the power amplifier, and this is the loudspeaker. Here one important thing is that the demodulator is connected to the RF stage through a circuit, and that circuit is known as AGC. AGC stand for automatic gain control. And there are some tuning circuits are also there, and these tuning circuits are tuned according to the requirement of the systems, and this tuning is known as ganged tuning, which we will discuss later on. First we will discuss the working of each block one by one. First of all, we will receive an electromagnetic signal. The incoming AM wave is picked up by the receiving antenna. This is the antenna, and this and amplified in the RF section, which is tuned to the carrier frequency of the incoming wave. This RF stage is nothing but there are some amplifiers which will amplify the incoming signal which is received by this antenna, and this RF stage is tuned to the carrier frequency of the modulation system. Whatever modulation system we are using, whether it is amplitude modulation or it is frequency modulation, our system is tuned to a central frequency. That frequency is known as the carrier frequency. Let us suppose the output of this stage is Fs. So this Fs is given to the mixer. So another component of the mixer is local oscillator. As you know that what is a local oscillator, it will generate a frequency. Let us suppose the frequency is denoted by Fo. So the frequency of this local oscillator is selected in such a way that the output of the mixer is an intermediate frequency which must be equal to Fo minus Fs. In some case it is also Fo plus Fs when we are selecting the frequency on the higher side, but for example we just for sake of simplicity we are taking the intermediate frequency here is Fo minus Fs. The output of I am repeating once again, the frequency of this local oscillator is selected in such a way that output of the mixer, which is Fi, is equal to Fo minus Fs. And how we select the frequency of the local oscillator? With the help of this tuning. This tuning is, which I call you, gang tuning. It is why it is called gang tuning, because it is done in a in a single step. Tuning of this RF stage as well as tuning of this mixer and tuning of the local oscillator is done in a single step, or by we can say by the help of a single command. So it is known as, because these are ganged together, that why it is known as ganged tuning, because they are working simultaneously. So the output of this mixer is given to the IF amplifier. It is intermediate amplifier. It will amplify this Fi frequency. Then this frequency is given to the demodulator. As we know that the function of demodulator is to get back the message signal from the modulated signal. So then again, according to output of this demodulator is given to the audio amplifier, because now we have the message signal. Message signal is the audio frequency signal, so we have to amplify it, and we will amplify that signal, and with the help of an amplifier known as audio amplifier. One thing must be keep in your mind, that here I have using the radio frequency and here I am saying the audio. So there is difference, because at this point we are getting the high frequency signal with from the antenna, but here after the demodulation we are getting a low frequency signal, that is message signal. So we are using audio amplifier. Output of the audio amplifier is given to the power amplifier. Why we use power amplifier here? Because this output has to be given to the loudspeaker. And as we know that a loudspeaker is a transducer which will convert the electrical signal into a sound signal, and for giving signal to the loudspeaker we need a high power signal, so power amplifier is used here. Now what is this AGC? AGC is automatic gain control. This is a circuitry which we can say this is kind of a feedback. A feedback is given to the output of this demodulator to the input, and the gain of the circuit is controlled according to the output. If we have to increase the gain, the signal is given to the RF stage and it will improve, or we can say it is basically a multi-stage amplifier. This is multi-stage amplifier, this RF stage, so it will amplify the signal according to the requirement of the gain. So this is basically the working of a super heterodyne receiver, and super heterodyne receiver is a very famous receiver and is more suitable for the majority of the radio receivers applications like amplitude modulation, frequency modulation, communication, single sideband, TV, and even radar receivers. They all use the super heterodyne receiver. One thing is there, why it is called heterodyne, because we are mixing the two different frequencies here. So heterodyning means mixing the two different frequency, and super means it having the so many, we can say, complex operations are going on there, so it is known as super heterodyne receiver. This is one of the very important topic of the communication. So this is all about super heterodyne receiver.